Inside Amazon's warehouse full of robots. Now that the technology industry has come to the forefront of political debate, the most important topic of discussion is not to limit the influence of tech giants like Facebook and Google. It is about job automation and the huge impact this is expected to have on American workers. At the center of the conversation is Amazon, a company that employs hundreds of thousands of employees in its vast warehouse network. The company's investment in robots and other automation technologies means that one day it could become one of the biggest job shredders. In 2012, Amazon spent $775 million to buy a new robotics company called Kiva Systems that owned a new type of mobile robot that could carry shelves of products from one worker to another, reading the barcodes on the ground to get directions. This acquisition may lead to an almost complete automation of the warehouse sector. Today we are going to give you a tour of one of the warehouses which is chock full of robots performing efficient labor. But before we begin, we would like to ask you to subscribe to our channel and press the bell icon to receive instant updates from our channel. Now, let's begin. Bert and Ernie, Scooter and Kermit may have started out as cute Muppet characters, but they are now part of a team of robots stocking goods in Amazon warehouses. Amazon showed off its newest mechanical employees in a blog post focusing on how it uses robotic research to improve the workplace safety of its employees. For example, Ernie is designed to take containers of boxy products known as totes off shelves at different heights, and then use its robotic arm to deliver totes to warehouse workers at standard heights. The goal is to reduce the amount of access or bend that employees have to perform. Innovations with robots like Ernie is exciting because it makes the process faster besides making the facilities safer for workers. Scores of robots like Ernie are working in an 855,000-meter warehouse in North Haven, Connecticut. It is one of the 50 automatized warehouses in the world, and one of the 5 operating in Connecticut, including another fulfillment center about 30 miles in Windsor, a package screening center in Wallingford, Amazon's logistics delivery station, and Amazon Air Hub in Hartford. The materials handling systems are impressive, to say the least. There are 10 miles of pneumatic conveyor and sorting, several thousand independent mobile robots from Amazon Robotics, and an automatic labeling system after packing. And that's just what you see. Even more impressive is what you don't see. That's the sheer scale of Amazon's mechanized ecosystem and the artificial intelligence behind the solutions. The software and algorithms developed from the experience of shipping billions of packages over the past 28 years. Those algorithms and software determine how Amazon can place millions of SKUs over 100 million items across 185 warehouses to meet the promised delivery dates. Combine that with Amazon's extensive network, and you have a customer-focused supply chain that is impossible to replicate. While anyone with a reasonable budget can incorporate mechanical picking technology and more than 10 miles of pneumatic conveyor and sorting apparatus, automation alone cannot seal the deal. That, in our opinion, is the secret to Amazon's success. At the opening end of the supply chain are the cross-dock facilities. Here, robots break down pallets and shipping containers into smaller units allocated to warehouses according to local requirements. For example, the North Haven warehouse probably has a good supply of Yale-related goods because the university is just down the roads. Sorted items which are small enough to be handled on a conveyor and the sortation system go to facilities such as North Haven, while bigger ones go to facilities designed to handle large items. At the North Haven facility, the newly acquired goods are decanted in totes, including products that can be shipped in transportation packaging. Those totes are then transferred to one of the 4 levels of the selection module. In each level, robots and storage cubes are behind the caged enclosure, select pick stations, and stow stations, as Amazon's replenishment facilities are known, are lined across the length of the storage area. There are some interesting innovations to be noted in the pick modules, as in the old Kiva facilities, only a handful of associates are allowed in the caged enclosure with the robots for rectifying problems like something falling to the ground from a storage cube. These associates wear a special vest that communicates their position to the robots to avoid collisions. During the stowing process, you see another innovation made by Amazon Robotics has added to Kiva's program. The old movable industrial shelves used in the Kiva system have been replaced by a four-sided storage cube with soft and flexible shelving. While two sides have been spaced for larger and deeper objects, the other two sides are dedicated to smaller objects. The product is held firmly in place by contraptions that look like simple exercise bands. Put away is random to maximize the cube's capacity and depends on the experience of stow associates. But lights highlight the shelves where the business rules of the system determine that the product should not be placed. The associate scans the object into place and confirms the put away by pressing a button. Items that appear to be defective or not properly scanned are placed in a hospital tote that is referred to a special team. As far as the customer experience is concerned, this is one of the first quality checks. Picking occurs simultaneously with replenishment. In that process, the order selector receives commands on the screen, and the light illuminates the shelves where the products need to be picked from. When the totes are completed, they are pushed onto a takeaway container. When the storage cube has been picked fully, the robot moves in front of multiple cameras near the workstation. The system analyzes the captured images to ensure that the right objects are still in the cube and that the wrong objects are not selected before they go back to storage. That's the next quality check. Elsewhere at the facility, items that are expected to be ordered in bulk are kept at the pallet level on pallet handling robots that are delivered to a workstation for picking. From picking, totes are transferred to a multi-line or single-line packing station. When the system tells the packer the size of the box, that should be used if the item cannot be sent to its original packing. The packer seals the box, applies required labels, and places it on the outbound conveyor. Packages then go to the weighing and cubing stations that ensure that the weight and the size of the package are within the expected limits. If so, the shipping label is applied automatically. Amazon calls this process SLAM, an abbreviation for Scan Label Apply Manifest. After that, the carton is taken off the conveyor to the inspection department, where the package is opened and the contents are verified. Once the package is verified, it is sorted and transferred to a trailer. Sustainability is also embedded in the delivery equation, with algorithms deciding the most sustainable way to fulfill an order and maintain customer satisfaction. When you come to tour such highly automated sites owned by a company like Amazon, it's easy to get a little nervous, like meeting celebrities. Once your visit here is complete, however, the thing that will stick with you will not be the automation, brilliant as it may be, but the amazing innovation and ingenuity that Amazon has brought into the game to ensure flawless ordering and delivering on customer experience. The intelligence and learning needed to do that, things you cannot see, are secret to Amazon's remarkable success. This brings our video to an end. We hope you liked it. If so, leave a comment and subscribe to our channel for more informative content. We'll see you in our next video. Take care. Bye.